Hi everyone, and welcome to week 5. In week 5 we're going to talk about Python and its relationship to incident response activities. I was involved in an incident response activity that was related to this, specifically with the Heartbleed vulnerability that occurred several years ago. And I want to kind of introduce you to Heartbleed if you haven't heard about it, just to kind of give you some background on how it worked. I did this work inside a power utility that was trying to determine the potential impact of Heartbleed. So I'm going to kind of walk you through that process. I'm going to kind of give you some truths, myths, and lessons from the actual practical application of investigating this. So first question is, what was Heartbleed, or what is Heartbleed? Heartbleed at its core is a software bug that was introduced into the OpenSSL, or Secure Socket Layer in TLS cryptographic library. When the bug is exploited, it can leak up to 64K bytes of server memory to whoever is actually exploiting the bug on each successful attempt, meaning that I could do this over and over again. And information that could be inside memory could be things like passwords and credentials and keys and all kinds of information. This is the information from the US CERT that talked about the Heartbleed vulnerability. If you want to learn a little bit more about it, you can definitely go there. A couple of interesting facts. When was the bug introduced? In other words, when did this software bug enter the Heartbleed, onto the OpenSSL source code that's used by so many different vendors? It was introduced at 11:59 p.m. on New Year's Eve in 2011. A developer was actually making a release of the OpenSSL library and introduced this bug at that time. Interesting time. So when was it discovered? If it was introduced in 2011, when did we figure out the bug was there? On April 1st, 2014, 821 days later. Now that's a zero-day vulnerability that was out there for multiple years that people could exploit. So who discovered the bug? Neil Mehta of Google's security team actually discovered this, and based on that, I want to kind of give you a deep technical definition of how the bug works. So a client accessing the server says to the server, "Hi server, are you still there?" Basically checking to see if it's still in existence. If so, reply potato, 6 letters. The server responds potato. The second request is sent to the server, says, "Server, are you still there? If so, reply bird, 4 letters." It replies bird, just as you would expect. However, "Server, are you still there? If so, reply hat," with 500 letters. And here's where the problem was. It responded with hat, but it also responded with everything after hat that happened to be in memory. So those additional, in this particular case, 497 characters that happened to be in there in the information that was on the page. The cartoon was supplied by webcomics. That's the web address if you want to go take a look at it. It's kind of a funny description of what happened, but it's a really great description of exactly how this worked. What was the immediate reaction once the information was released by Google that this was out there? Certificate revocation during the heart of the announcement, April 7th through May 7th, was the largest revocation of certificates in history, because the potential revealing of private key certificates actually occurred because of the information that could have been in memory. So that was just the initial response. So the Python script response was to discover infected systems. Since we understand how the actual bug works and how we could actually exploit it, shortly after it was discovered and announced of the vulnerability, a Python script was developed to probe systems to determine if they were affected or impacted by Heartbleed. If you're interested, this is a GitHub site that has an example of the source code that was involved. The ICS cert is a key component and strategy for securing control systems. and the primary goal was to build long-term common vision. And the ICS CERT leads this effort by responding to and analyzing control systems related incidents, conducting vulnerability and malware analysis, providing on-site support for forensic investigations, providing situational awareness in the form of actionable intelligence, and sharing and coordinating vulnerability information and threat analysis through information products and alerts. So, Truth 1, Heartbleed. ICS CERT advises the industrial control system operators to contact their product vendors regarding Heartbleed status. Sounds pretty simple, right? Well, truth number 2. Many utility operators have legacy or end-of-life systems that have no vendor support. Vendors may not respond in a timely fashion. Vendor information when provided is not always reliable. If patches or updates are recommended by vendors, the patches must be validated in a test environment. Patching of some systems due to their availability may not be possible at all. In some cases, this took months. In the best case, it took weeks. Truth 3. Vendors actually put out notices that were misleading. In the case of Hewlett-Packard integrated lights-out products, they suggested do not use the OpenSSL library and are not exposed to the vulnerability known as Heartbleed. However, there is a bug in these libraries that will cause the first generation devices to enter a live lockup situation when vulnerability scanners check for the Heartbleed vulnerability. So, therefore, Hewlett-Packard released a specific announcement that could have then been exploited by anybody to turn those devices off by simply scanning for the known bug. Truth 4. Any component connected to the ICS network that is based on Microsoft technologies may not be vulnerable because Microsoft does not use OpenSSL. Unfortunately, vague statements like this have resulted in utility companies not wanting to scan Microsoft platforms, as they took this to mean anything running on a Microsoft platform is safe. Obviously, this is not true, and many applications running within the Microsoft environment do use, in fact, OpenSSL. They also advise that scanning devices for Heartbleed must be done in isolated test laboratories, not in production environments. It's pretty obvious, however, that's easier said than done because they may not have alternate operating centers and alternate operating situations where they could test this within the environment. And even if they do, the vulnerabilities, if they were affected on those alternate operating environments, could still affect the production environment. So post-Heartbleed, subsequent to the discovery, researchers have discovered other flaws in OpenSSL that can result in man-in-the-middle attacks, denial-of-service attacks, and web server crashes. The truth number 6, which is really revealing, is that cybersecurity systems were impacted by Heartbleed. For example, systems deployed by McAfee and Symantec that were deployed in order to protect the environments also used OpenSSL and also were vulnerable to Heartbleed. So now we have the security infrastructures, application firewalls and content filters and DLP systems, and even the SIM from McAfee were impacted by this particular bug. So in summary, Heartbleed can be proven to be a very difficult problem. The cost and response remediation can easily exceed $1 million per utility. These challenges were ongoing for well over a year after the CVE was announced. Many new methods and procedures are needed to fully address vulnerabilities like Heartbleed. Non-production, fully operational test environments need to be in place, which are very expensive, and improved non-intrusive tools for responding to them. Incidents like this need to be created. And many of those have been created and worked on, and even many of them have been developed in Python. So hopefully that gives you a little background on how the Heartbleed OpenSSL bug had wide-ranging impacts across the industry, and how we did in fact use Python in order to be able to help discover at least those systems that were impacted by Heartbleed by developing simple scripts and responding to those very quickly.